students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the problems, numerical problems on gross calorific value and net calorific value of any fuel so that it can be selected accordingly. So calorific value, before going to that, we should know what is this calorific value. So the calorific value or the heating value of solid liquid fuel may be defined as the amount of heat given out by complete combustion of 1 kg of fuel, whether it is solid or liquid. Combustion occurs to generate heat or energy that can be used for automobiles or machineries. So this calorific value will define the heat that is generated for that particular fuel, so that we can accordingly select the solid or liquid fuel for that particular machinery or automobile. Okay, so this is expressed in kilocalories per kg at normal temperature and pressure conditions. In SI system, joule per kg or kilojoule per kg or megajoule per kg. So these are the different units that are present. There is also a unit calorie per gram, which is also can be used for expressing the calorific value. So there are two types of calorific values that are present: higher calorific value or gross calorific value. So higher if the name itself indicates that it is high in content. So it is the total heat that is liberated by complete burning of 1 kg or 1 cubic meter of fuel, including heat of steam. So HCV is higher calorific value, or it is also called gross calorific value. It is the total heat including heat of steam. Where does this heat of steam come from? Just because of moisture that is present. So we are considering this also for the HCV or the GCV, that is the gross calorific value. So it is given in the form of a formula, HCV or GCV, which is nothing but 33,800 carbon. This is given by Dulong, scientist Dulong. So he has proposed this formula for calculating the calorific value. So 33,800 into carbon content plus 1,44,000 into hydrogen content minus oxygen content plus 9,270 into sulfur content. So that is how Dulong has proposed this formula for the higher calorific value or gross calorific value. Next, lower calorific value or net calorific value. Net is nothing but what we get or we use for our purpose. So it is the total heat liberated by complete burning of 1 kg or 1 cubic meter of fuel, deducting the heat of steam formed by the combustion of hydrogen in the fuel. So when we are deducting heat, it means that HCV must be deducted. So therefore, HCV minus 9 hydrogen 9 into hydrogen content into 2466. That will give rise to the net calorific value or lower calorific value. These are the units. Kilojoule per kg, so that will be expressed in kilojoules per kg. So next, going to the problems. Calculate the gross and net calorific value of coal having the following compositions. Carbon is having 85%, hydrogen is 8%, sulfur is 1%, nitrogen is 2%, and ash is 4%. And the latent heat of steam is also given 587 calories per gram. So according to Dulong's formula, this is the formula that we can be rewriting this also like 1 by 100 into 8,080 carbon plus 34,500 hydrogen minus oxygen by 8 plus 2240 sulfur. Okay, so calories per gram. So they have given in calories per gram. So we are also be reporting in calories per gram. So now the given is carbon is 85%, hydrogen is 8%, sulfur is 1%. Now, nitrogen and ash doesn't contribute to add a calorific value. because ash doesn't contribute to any calorific value and nitrogen also doesn't contribute, so therefore we do not consider for that. And the HCV or the GCV of coal can be given as 1 by 100, 8080, 1 by 100 into 8080 into 85 carbon, that is present 85, plus 34,500, and what is the hydrogen? 8 minus oxygen is not given here, so oxygen plus 2240 into 1, sulfur is 1. So therefore we substitute the values in this formula and we get, after simplification we get 9650.4 calories per gram. So this is the GCV value for this coal sample. So if we want to calculate the NCV or the net calorific value or LCV, it is the HCV minus 0.09 into hydrogen into 580 calories per gram. So substitute the hydrogen value also here and we get 9,232.8 calories per gram. So if you see here, this is always high compared to the lower calorific value, because the latent here, the heat of steam will be removed in the lower calorific value or the net calorific value. Next, a coal sample has the following composition by weight. Carbon is 90%, oxygen is 3%, sulfur is 0.5%, and nitrogen is also 0.5%, ash 2.5%. And now calculate the net calorific value of the coal was formed to be 8,490.5 kilocalorie per kg. Calculate the percentage of hydrogen and higher calorific value of coal. We have to calculate the GCV. GCV we don't know, and also hydrogen content is not given. Okay, so we have to find out these two. So this is the lower calorific value or the net calorific value. So now let us see the formula. So it is the given one and the lower calorific value is 8,490.5. So higher calorific value is equal to lower calorific value plus it is rewritten from the lower calorific value formula, rewritten lower calorific value plus 0.09 into hydrogen into 580 kilocalories per kg. So substitute the lower, because already lower is given here. So therefore we are substituting the lower here plus 0.09 into hydrogen. We don't know the hydrogen, so we will be finding out from this into 580 kilocalories per kg. So this is how we get the answer and take it as equation 1. Now higher calorific value is equal to 1 by 100. This is the main formula, Dulong's formula for the HCV. 8080 into 90 is the carbon content. Then 34,500, hydrogen we don't know still, minus 3 is oxygen, 3 by 8 plus 2240 into 0.5 is the sulfur. These two doesn't contribute, no contribution, no calorific value for these two. So we do not consider for the calculation. So now we have substituted these values in this formula and after simplification we get 7,254.8 plus 345 H. H is always like that because we don't know the hydrogen value, kilocalorie per kg. So this is for the high calorific value of that particular coal. Okay, so continuing from that, so the equation 1, this is the equation 1, we got it from the first step. So 8,490.5 plus 52.8 hydrogen kilocalories per kg. So we know that HCV is equal to LCV and the formula is given with that. So we are substituting the HCV value here. If you see here, this will be substituted in the next step. So HCV value here. So HCV value here is equal to 8,490.5 plus 52.8 hydrogen. So from this we take the hydrogen common. Take out the common and now subtract 345 minus 52.8 and is equal to 8490.5 minus 7754.8. So now with this we get percentage of hydrogen by dividing the both the values we get from this after subtraction. We get 1335.7 by 292.2, that is giving rise to 4.575%. So the hydrogen percent is 4.575% because we have substituted the percentage values only, so we get the percentage value directly. Okay, now calculate the actual HCV. Now substituting with that hydrogen value, so 4.575 here, and we get 8731.8 kilocalories per kg. So this is the HCV value, HCV or GCV. Gross calorific value is 8731.8 kilocalorie per kg. Okay. So next, a coal has the following ultimate analysis. So this is they have done the ultimate analysis for the coal sample, and these are the results. Carbon is 84%, 84%. Sulfur is 1.5%. Nitrogen is 0.6%. Hydrogen is 5.5%. Oxygen is 8.4%. So ash is not given, even though anyways it's not going to contribute anything for the calorific value, and also nitrogen. So now calculate the gross and net calorific values for the sample using the Dulong's formula. So carbon, hydrogen, oxygen and sulfur is given here, and the gross calorific value of the coal can be given by formula 8001 by 100 into 8080 carbon plus 34,500 taken in bracket hydrogen minus oxygen by 8 plus 2240 sulfur given in the form of calories per kg. Okay, so kilocalories. So 1 by 100 is equal to, we have to substitute the same here. So 84 is coming from the carbon, and hydrogen is 5.5. Hydrogen is 5.5. 8.4, oxygen 8.4 is substituted here, plus 2240, and the sulfur value is 1.5 is substituted. Upon simplification, we get 8356 kilocalories per kg. So this is the GCV value, that is 8356 kilocalories per kg. Okay. The net calorific value of coal is equal to HCV minus 9H by 100. Even if we write like this, or 0.09H is similar. Okay, so 9H by 100 into 587. So that is the formula for the net calorific value. And now substitute the H value here. The hydrogen percentage is 5.5. So substitute here, and 8356 is the higher calorific value or the gross calorific value. And after a simplification, we get net calorific value or lower calorific value is equal to 8065.435 kilocalories per kg. So very simple problem, like they have already given the percentages, we just need to substitute and calculate the net and gross calorific values. So always the gross calorific value is higher to the net calorific value. Next, calculate the gross calorific value and net calorific value of a coal sample having 83% of carbon. Hydrogen is 1%, sulfur is 1%, hydrogen is 8, sulfur, hydrogen is 8%, sulfur 1%, nitrogen 1%, and oxygen is 4%, and ash is 3%. So do not consider this, not required. Nitrogen also not required for our calorific value. So now according to Dulong's formula, 1 by 100 is equal to, for gross calorific value, 1 by 100 is equal to 8080 carbon plus 34,500 taken in bracket hydrogen minus oxygen by 8 plus 2240 into sulfur, that will give that will give the units kilocalories per kg. Okay, so now substitute the carbon value oxygen value and hydrogen value, and the sulfur is 1% and substituted accordingly. Upon simplification, we get 1 by 100 is equal to 670640 plus 258750 plus 2240, and upon addition and dividing by 100, we get the gross calorific value is equal to 9316.3 kilocalories per kg. So this is the GCV or HCV value. Next, for the NCV or LCV, subtract GCV minus, this can also be written as 0.09. Okay, 9H by 100 into 587 kilocalories per kg. So that units we are reporting in kilocalories per kg. Upon substituting the hydrogen value 8% here, we get after subtracting 88 like LCV or NCV. Now we are reporting as net, so we take it as NCV. It is 8893.6 kilocalories per kg. So always GCV is higher than LCV. Just check it out after getting the problem answer, like GCV must be higher than LCV because the stream of heat will be present. Next, a sample of coal have the composition: carbon is 70%, 70.3%, hydrogen is 5.1%, oxygen is 22.4%, nitrogen is 0.4%, sulfur is 1.8%. Okay, now calculate the gross and net calorific value. So need not consider the nitrogen because it is not contributing to the combustion. So the calorific value, so according to Dulong's formula, 8080 carbon plus 34,500 taken in bracket hydrogen minus oxygen by 8 plus 2240 sulfur. So we are reporting in calories per gram here. So this is nothing but we can write as 0.01, and now substitute the carbon value here 70.3, and the hydrogen is 5.1, and the oxygen is 22.4. If you see the oxygen value is very high, it means it has steam. Steam is high. Heat of steam is high. Okay, then 2240 into sulfur value is 1.8. So after substitution and simplification, we get GCV is equal to 6513.3 calorie per gram. Okay, so now substitute in the net calorific value formula, GCV minus 9 into H by 100 into 2260. So H, this is the H value, hydrogen 5.1. Substitute in this and we get after simplification 54, or this is not kilocalories. So net calorific value is equal to 5475.7 calorie per gram. So these are the gross and net calorific values for this coal sample. So solid fuel coal sample has this GCV and LCV values. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.